Hello, hello, hello. Welcome to another episode of watching Axel trying to progress on his Tetris clone in Elm. I've been looking forward to this episode. Going to do some interesting stuff today. First thing I'm going to try to tackle is to rotate the pieces or the current piece on key press, and if I have time left, I will look into actually spawning random tiles instead of what we have now, where you can see I always spawn the same blue L piece. So if I'm aiming always at 30 to 60 minutes, so if I have enough time left after we implemented the rotation, I look into this as kind of a reward. Should be a rather small task as well. So just to revisit what we've done so far, as you can see already, I can move the tiles with the key presses. We have now collision detection, so that if the piece cannot drop any further, it will be baked into the board and we'll spawn a new piece. So for the rotation, I took great inspiration from Sean LeBron's Tetris clone and closure script that basically spawned the idea of doing this stream about the Tetris in the first place. You can really recommend his presentation here. It has lots of great insight about the algorithmic intrinsic and tricks to deal with certain problem pieces, and he has this great slide about how he implemented the rotation. So basically, I don't know closure script really, but it is enough to see that to rotate a piece or a position, an XY position, you just have to, as output, you use the inverted Y position as the new X position and the original X position as Y. And I really love this presentation. It has all these nice interactive elements where you can see where he really visualizes the difficult part or the tricky parts about but yeah, let's try to take this idea and turn it into something nicely strictly typed in Elm the way I like it. Okay, so without further ado, let's jump right in. Is the font size? Maybe give it another 2 bumps. Okay, just going to undo my hack here to keep my my lobby animation going. Cool. So something that I was wondering before I started today is how many lines of code we have produced so far. We're still below 500 lines, and I feel like, given how much white space is in idiomatic indented Elm, I think that's really concise still. But yes, so let's see I haven't thought yet about where is the good entry point for this episode. I would argue we probably want to extend our definition of the key presses and possible keys that can be pressed and whatever function is called in. So I think I'm kind of working myself top down in that sense. So I've completely forgotten how my key things are defined. So I'm just going to search for key in my on key down. I see there's a key data type already. Move piece. That's also interesting. So I'm curious, do I have an alias for key? No, it's probably an algebraic type. Type key. All right, that's great. So let's right arrow, maybe add another one for the rotation. Oops, change to A. Down arrow. And let's see, the compiler tells us now, yes, we have a case statement that iterates, or doesn't iterate, that matches over the key type And we have to handle this new case. So let's go there right away. Move piece. Do I know what's up today here? Do I have the wrong keyboard layout? No, I'm just unable to type. So I will not try to implement it in the spot. I just want to make my compiler happy again. Down arrow, we will do nothing basically. And now I'm curious when we actually produce a right arrow. So I will look here and I see already, yeah, to key. That's probably a place I have to extend. So I will do arrow down, key down, change to a down arrow. So in my show notes blog article for the last episode, I went into detail how if we want to debug something, we have to use this weird underscore expression. Debug.log foo, and then value. Or actually, we can also just do strings. Let's just do a string for the sake of putting out something meaningful. Compiled. Let's open the dev console. So boom, foo, arrow down, food 42. Where am I logging 42? Is it because because the key listeners are registered globally and not reloaded. So actually I got a hint on Twitter, shout out, am I logged in? From Martin Janicek that I can actually use the debug statement without the let block. So thanks for pointing that out, Martin. I quickly demonstrate how we can actually debug the string that we are debugging, logging the debug string without using this separate block. So what works is I can actually write here debug.log the string. It does compile. Quickly going to reload here. And as we see, it works just as well. And the reason behind is that the log statement always automatically returns the value and the type of what we log here as second parameter. So that's why I can actually, if I have an expression that I am using already and just want to log it, I can just replace the expression with a debug statement that logs it. So thanks again for pointing that out. All right, back here, nothing is logged. Arrow down, or actually I should confirm, is it actually arrow down? Arrow down, yeah, wonderful. So we'll stick with this. And now we can go back to down arrow. So move piece, left, right. Yeah, I think this will be obviously the place where we want to rotate the current piece. New position. Yeah, okay. If we have a down arrow, then actually the position of the current piece does not change. So that's right, but the nature, the piece, the tiles of the piece, how I call it, they change. They have to be rotated. So maybe we just say new tiles, do the same way. New tiles equals big case statement here. I'm also like in Elm, I'm significantly less worried about writing like not pretty or not optimal code in the beginning. I mean, yes, for A, because it's a pet project and not work code, but also because it's much less worrying to having to refactor something. Like usually if you have something working and you just want to shuffle around statements a bit to make it a bit look nicer, then you get a lot of help from the compiler. And that's obviously different in interpreted language where you don't have a compiler. Cool, so new tiles, and I will just look up how the current piece type is defined. I believe it's an alias, current piece, so we have position, tiles, color. So I will create a local expression here, current piece.tiles. So our tiles stay exactly the same if we just move to the left or the right. So I will just replace this, and this is where the magic happens. So let's create a little LED block if I manage to hit the right key. And as I said, I want to do this greatly inspired by this expression, so I'm just going to create a rotate function. Rotate, and it's going to get a position as input, and it's going to create a new position as output. Minus y and plus x, so it's minus ty x. So that as we see here on the right, the tiles are just a list of positions. So now we have a function that can rotate one position. So what we have to do is use our good old friend, the map function, to rotate all the tiles. So rotate it. Oh, actually, I think we can just return it directly for the case where the down arrow is pressed, where we just say, I think we imported we exposed map explicitly, so we can just call map, and we call rotate on tiles. Let's see what the compiler says. Compiler is happy. Cool. Reload. Moving still works, and rotating does not work. Why does it not work? So now we can just right away apply our debug trick here. Log. Rotated. Probably redundant, those parentheses, but I'm not worried. Okay, cool. So, I know, I never use my new tiles. That is, of course, makes little sense. So here I have new tiles. Oh, okay, interesting things are happening. Also, I don't know, yeah, that's weird. I don't know why these values are so high. I would expect our tiles to have a range between 1 and like minus 1 and plus 1. I'm a bit confused why we have so high values, so I will just log the current tiles. Whoops. Now there's no debug output at all. Because I'm in the console, it doesn't register my keystrokes. That looks better. Because here I have X instead of TX, so I actually used the wrong. Okay, that looks better. And now we can map again, map, rotate tiles. Yeah, that's pretty cool. Wow, that was a lot quicker than I expected it to go, but I'm always up for a positive surprise. So satisfying. Cool. So, I don't know. I promised I will look into... Yeah, I think it's nice to spawn new tiles first, and then if we even after that have still time, then we could look into something else, or I can look into something else, which is actually preventing like moves based on key presses that are not possible. Like I can just move a tile into other tiles, so that's something that should be prohibited, of course. But let's do something nice first. So what I want to achieve is that if the tile cannot be dropped and we spawn a new tile, we want to pick a random one. And random is interesting in Elm because it's not pure, like generating random. If I have a random function, it cannot be pure, because by definition, or by the pure mathematical definition, like a function always gives the same output value for the same input value. So the random function to start with doesn't take an input, so it only can really give an out, like it can only produce one value based on the static definition. So let's look at random with Elm. I'm sure the documentation has something to say about this, if not even the random manager. Yeah, even the guide has a chapter about random, so that's nice. La 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 la. What does it say? Random generator. We are using the Elm random package. Okay, cool. So that means there's a package for that in the standard library. We're going to consult that in a bit. Core ideas, blah 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 blah. Okay, let's see. Need to generate, yes, orange, blah 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 blah. Import random, so probably can grab this. I'm not sure if it's actually part of the SDK or if we have to import, add a new dependency. But we'll just see, import random. Okay, cool. Elm compiler to the rescue. It tells us directly which package to install and how to do so. Yes. Restart the build script. And probability, mindset shift, and I think here's in a whole paragraph again explaining a bit about the particularities of Elm and randoms. So what is our random float? Generator. Create a command that produces a random value. Say you want to, yeah. So that's where the magic happens. So the problem that we don't have a function that can generate random numbers is solved with the command pattern, or with the commands. I don't know, have we talked about commands already? We had talked about subscriptions, I believe. Yeah, we haven't talked about commands yet. Maybe we can revisit that quickly. Commands and subscriptions. I mean, they are tightly, as it indicates here already, it's tightly related. So we talked before about how subscriptions are basically a way for our Elm application to react to something that has been triggered or caused outside of our control. If we look back into how we use them, for example, the timing event that gets triggered every 300 milliseconds, like we convert this into a message gravity tick that we defined ourselves, but like the way we register something or we can react to those events is through the subscriptions. The same way with the on key down event, the global on key down event in our app, like it's not something that we can really tie to a specific component or node in our DOM. So we register this subscription with which then ultimately generates a message in our application again. The commands. Let's go back to the guide here. I don't know. Do they have a nice diagram for that? The commands are basically the counterpart to the subscriptions. So instead of listening to something that we haven't caused, commands is basically triggering something or just sending a message, fire, forget something without, like, normally if we want to have an effect, a cause and effect, it's tightly coupled through this message system that we say, like, if we click this button, then we trigger this message. And with commands, we can trigger basically something without specifying a concrete message. I'm not sure if that is probably a poor explanation. I probably should have thought a bit about this before. But that's why basically we see this command signature here. But I think I'm just going to try to implement it, and then hopefully it makes a bit more sense. So basically that's also the reason why our update function, let's see, where's our definition? So that's a good starting point as well. Why our function, our update function, does not only return a model. Like the more naive way of looking at an reactive programming or an Elm application is, the update function takes a message, a model, and creates a new model. But real world Elm application actually return this tuple from model and command message. And the reason for that is exactly, the random makes good example for that, because when we want to drop the current piece and want to generate this random new piece that we want to spawn, that is where we are out of luck if we look at it at this pure functional approach, because there is no random function. So that also means we cannot generate a random piece, and without the random piece we cannot generate a new model. So we are stuck without our old model, but still we want this, like we want to generate this random number. And to generate this random number, basically what we do is we shoot out this message, it's not a message, this command, to say, give the computer our imperative underlying JavaScript layer the command to generate a random number. And because this usually involves the current time, like that's basically our link into our imperative world that we don't have synchronous access to with regular functions. So similar to the way we say, like, we want to spawn something every 300 milliseconds, we basically say with this, we issue this command that says, we want this random number, take your time literally to generate it. And that's what we can do with the command here. So without further ado and more waffling, I'm just going to try to use it, and then we'll eventually see how it all ties together. So we want to generate a command, a message, and the command has a type parameter, message, that is unknown for the Elm standard library, because every application has its own message type. That's why it's a lowercase type parameter. But of course, in our application, it will be our message type. And basically what it says, like, I'm firing off this command and the result will be of a message, or as part of the reaction, we will probably generate a message of this type. Okay, cool. Read through, learn how commands work. Coming frustrating, yeah. Okay. So we want to call... Actually, I forgot how this works. Maybe we consult the guide again for a good example. Random. Yeah, so here we see something else, like or something similar. So we'll just copy this expression and then make it work for us. Good old copy and paste, Stack Overflow style. Random generate, new phase. So let's look at the type signature again. Generate, first parameter is a function from A to message. A will, like, the random number we want to produce is the number between 0 and the number of different piece definition or tile definition that we have. So that's basically the message. The new phase here is we want to switch it out for the message that we want to generate when we finally have the random number and want to produce this new tile or place this new tile. So how do we call it? New current piece. Random between and do we already have an array for where we enumerate all our JPs, all our piece definitions? Where do we use JPs? Just searching all the occurrences. So no. Okay, so we'll just create a constant here. Piece definitions. Let's call them piece definitions. So we have our T piece and our J piece. Cool. So now, okay, let me just close this window here on the right. So that means the random number should be between 0 and length of piece definitions -1, I guess, because it's 0 indexed access. Whoops, where did my 1 go? Okay, so that looks good. Let's see what the compiler says. The compiler says it doesn't know length, so quickly go to our imports here and add length to the list of explicitly imported functions. And now it says cannot find a new current piece variant for our message type, which is correct. So let's see where we define that. Message. Okay, let's add the message. So now it should be happy, right? No, it's not happy because it says random generate wants the first argument to be A to message, but it is a message. So we cannot just put the value in there. We need to pass in a function that takes an A and returns a message. And this is a bit slang for you're missing a parameter here, because by adding a type parameter or an attribute to our message, we are basically converting this variant name into a constructor function that takes one argument. So that's good, but it's still not happy. Oh yeah, because I deleted the 0 there. Random int. All right, so that's great. But we have a new compiler error, which tells us that we didn't handle the new current piece variant in our update function. In line 191, let's go there. Oh yeah, so that's actually quite trivial. Let's keep the no variant at the bottom. New current piece. Piece index. And let's try to make it compile before we make it work. What is wrong? Oh yeah, it's not an equal sign, it's a little arrow. Cool, compiled without arrows. So that's great. So I just dropped this command here, but that actually makes a little sense, I would say, because this way we generate a random number each 300 milliseconds, which is obviously not what we want. So I'll just cut this expression because I'm sure I need it elsewhere. The question is, when do we actually want to do this? And the answer is, oops, not command new, but command none. And the answer to that is, after we drop the current piece, like it depends. Not every 300 milliseconds, obviously, but rather when we cannot drop the current piece anymore, then we want to generate this. So that also means, since we want to conditionally generate this command, we basically have to include it in our return value here. So instead of only returning the value, the model here, we are actually going to return the whole tuple. So if we can drop the tile, then we don't want to generate a random number into a new tile, so we'll just return command none. Whoops, yeah, that's... And of course we also have to change our signature, so we are not only returning a model, but we are returning the tuple of the model and command message. And here, like, it seems insignificant at the beginning, or you don't really know when to write the uppercase or lowercase, but since I know basically, I mean, let's see what the compiler says. I wrote command new again. I will in a bit I will come back why we write command uppercase message and not lowercase message, but I will want to make it compile first. So now in our update function, it's rightfully complaining about that we are wrapping another tuple around this. So now that the drop current piece function is already returning the right tuple, it compiles again. So now back to the question is, why do we write uppercase, sometimes uppercase and sometimes lowercase? So lowercase we always use if at the time where we write it, we don't know what concrete type will be used in this placeholder. But at this time, we are sure that the command will be used will be parameterized with the type, our message type, because new current piece is a variation or a function that produces a variation of our type. So probably even if I pretend to not know it, the compiler will probably tell me, but I know, and you should, yeah, like it can only be uppercase message, like it can only be your message type. So you should be specific about it. So that's why we write uppercase. But it takes a while to get used to these subtleties eventually. But luckily, the compiler is very cooperative when it comes to pointing out those things. So now what's happening is, if we cannot drop the current piece on the gravity tick, we will bake the current piece into the board, but we will also generate a new current piece directly at this, the default piece, our blue J, and what I chose last time. So, and we generate the command that will generate the actual new random tile. So it's a bit off here, and we should fix that. Or maybe we have a look. What actually did I already implement? What's happening? New current piece. So I know there's still a logical flaw in this, but before I address this one, I just want to spawn the new piece based on the random number, because that will also better expose what's actually wrong with the current state. So maybe we make a new function, spawn piece with piece index. And copy this here, right? And I will write a signature, feeling it today. So spawn piece. Oh yeah, and there's already a mistake in it. Like it's what I love about writing signatures, it forces you to think what you want to do. And actually I want to take the integer object class, but I also want to take the old model, and I want to generate a new model. So I can already tell I will have to pass in the model here. I get it here. And I want to update the model with a new current piece. Let's call it new piece. Have a little let block. And I will steal the definition. Where was it? Can drop. Here's a nice expression that I can steal from. Go to the last place I edited. Indent a bit less to do. What did I call it? New piece. And position should be in the top, so that can just be fine. And now I just want to switch out the constant jpiece expression for the random one based on the index that got passed in here. So say piece definition def. Oh, this piece def is a bit shorter. And piece definitions, and we just drop piece index from this and take the head of that list. So just to deconstruct this expression, nothing fancy going on. We have the list of all the piece definitions, the T piece and the J piece, and then from the beginning of the list we drop n definitions from that based on our index. So if it's 0, then we drop nothing. We have the full list of definitions, and with head we take the first element from that, and that will serve as our template for the new piece. So we'll swap that out for that. There's only one caveat, that is that the head doesn't definitely return a list item or an element, because we can also call head on the empty list, so it returns a maybe. So that means what do we do in the and like we know that cannot happen, but to make the compiler happy, we'll still have to produce a default. So we'll just say maybe with default, and let's say the t-piece is our default, because like the way we generate the random numbers, we cannot guarantee that the random number is out of range. Like we know that when we generate the command, we put it in the range there, but theoretically nothing keeps us from generating random numbers up until 2000. And then if we drop 1000 pieces from our smart piece definitions, then so in some way we have to explicitly deal with the fact that this can theoretically happen. And I decided to deal with it by choosing the t-piece as a default piece. Cool, so that's good. Let's see if the compiler thinks so too. Compiler says it doesn't know drop. It's part of the list module, so I expose this here as well. Now it says the same thing about head, so I'm going to add this too. Now it's happy. So let's give it a good refresh here. And there's another red T. I'm wondering if I will ever get to see a different piece. And there's a blue L. Oh, that's pretty awesome. I'm really curious. I fear the logical error that's still in our application, we will never get to see it because it is only very briefly visible. Beautiful. But yeah, let's fix it nonetheless, because like it's also a great exercise or showcase again for the strength of a statically typed language. So let's go back to the function where we drop the piece eventually, or generate the command that will, like here is the command that we issue when we cannot drop, but we also set the current piece to the blue J piece, that is. So that means when we cannot drop the piece, we will definitely first put a blue piece on the top of our board, and then we spawn this new command, random function, and this does something outside of the program to generate a random number, and then generates this command that will basically replace the current piece that we just spawned on the top of the page with the statically blue J piece as a constant. It will replace with one based on our random number. So there's a potential for like this time between where we cannot drop the current piece, but the random number is not generated yet. We should theoretically see this blue L, but apparently the time frame of that is so short that we never actually see the blue L appear before we replace it with the red T. But nonetheless, it's logically not right, so I want to fix it. Mantra in a lot for a lot of people who like this strict functional programming or strictly typed programming is make impossible states impossible. So this should not happen. So, but the problem is current piece by our definition of, let's look at the type definition of our model type. The current piece has to be a current piece. Like I cannot put nil there or undefined. Like it has to be a current piece. So if I don't want this blue J to appear, what would I write instead here? So, and the equivalent to nil or undefined in Elm is nothing. I would just want to say, like, until I've spawned the new type, please, I don't want to see anything there. So that means we have to extend our type definition here to, instead of say current piece, we say maybe current piece. And this is that's one of the pieces where I just like, if you have experience in imperative programming, then you know introducing this like can have so many negative downstream effects on your application. If you say like, oh, something where I used to always have a value can now suddenly be nil, is basically, especially in dynamically typed languages like Ruby or JavaScript, is basically now you have to test the whole program, because you don't know when you access this value and try to call a method on it, and it just gives you the good all unexpected null pointer exception, or whatever it's called in the different languages. So let's see how we deal with that in Elm. Cool, I hit save on my program here, replace this, and well, it's only 2 error messages. That's not too bad. 2 places we have to address for now. Could be some more coming up, but let's see it for now. Line 313. Here it says drop current piece, and we're trying to access position on current piece, but current piece could also be nothing. So again, like the way I'm addressing it now is probably not the way I want to leave it in a long-term code base, but I how do we do this? Like the most naive way would be to say like case current piece off, just, and actually I will not destructure this here, so I can write case, so this, just so I have the identifier, the variable name still free, so I can write just current piece here, pattern match on the just case. And actually I can handle the trivial case here before. So if we don't have a current piece, then I also don't want to do anything basically. So I will just return command the previous model and command none. And yeah, that makes the compiler already happier. Next complaint, line 235. Boom. Same scenario, move piece on current piece. So I will just again not restructure that here right away. Case model off, nothing, same procedure. Then I'm just going to return the previous model. There's nothing to move obviously, but if I have a current piece, then I'm executing the code that was executed before. Indent, save. Yep, looks good. All right, and as I said, like it's sometimes the compiler cannot detect all errors right away. You have to fix some before you can figure out the rest. So what is it complaining about now? Line in our, oh yeah, actually this might not even be the example for that. Yeah, I made a mistake. Okay, now it's line 274. Current piece equals move piece. What is it not happy about? This move piece is a value, blah, 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 but it should be, yeah, okay, cool. That is correct, because now also if we assign something to the current piece attribute, we also have to make sure it's a maybe. So I just pop in a just here. Same here, line 332. Current piece is just dropped piece. And in line 388, like from now it's basically like making sure that all the code either handles just and nothing or produces always at least a just or nothing. So now board view also takes the current piece. So let's here. Let's just say maybe current piece. Board with current piece is let's say this is case maybe current piece off, nothing, then it's just board like this. That's basically the combination of the current piece with the current state of the board. To be able to render it, we place the piece on in the current board, but if we don't have a current current piece, then there's obviously nothing to play. So it's only in the case that we have a current piece that we have to bake it in. Fix that. And now when we I guess that's when we initialize 165 current piece. Yes, it's again where we assign something. So we say just current piece. Do. 224. New piece again, just popping in adjust. And it's compiling again. So let's see. If that still works. It looks good. Just waiting for one blue L. There we go. Success. Cool. So that's basically everything I wanted to achieve today, so I'm pretty happy with that. Find it interesting that what I thought would take long, the rotation was done super quick, but what I thought was just a quick add-on to spawn the random tiles, that took actually a lot longer than I expected it to take. So again, some new insights there. So actually, since we have 8 minutes until I filled a full hour. So I want to do one additional step before I call it a day, which is that the initial tile that the game starts with when we reload is always the red T, and that's because if we go back to the init function. Where is it? Here we go. Like we have hard coded the current piece to red. So the nice thing is now we have everything in place to generate a random piece. So basically we can just say like, okay, we start out without a current piece, nothing, and we can just copy our expression that generates a random number. So, and the message that will eventually add a new tile. So what was it called? Generate. Just steal this line and replace it with this. So that should actually do the trick. Just compile, it compiles. So if we refresh, you can see now sometimes we get red tile, sometimes we get the blue L. Cool. Awesome. Thanks for staying with me again. Yeah, I'll make sure to create a branch on GitHub if you want to check it out, and write a few lines in the show notes after that. Thanks for staying with me, and see you next time.